Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Zulfahmi Zainal. Today I would like to present my thesis project, the effect of surface roughness on glass fiber reinforced polyester mechanical properties. First of all, I want to thank to Associate Professor Syukur bin Abwangsan to guiding me to complete my thesis project. This is problem statement. The fiberglass received from supplier need to undergo quality check by performing several testing, including a tensile test. This test will evaluate the strength of fiberglass composite, the differ value suspected due to level of surface roughness at the tap bonding area, which is hold and protect the sample during testing. This is my research objective, to study the average bond stress of GFRP double strike joint due to effect of different size of sandpaper and semi-inclusive. For scope of research, this project is to investigate the main contribution to the bonding strength of tensile tap area like surface roughness, adhesive material use. The processing of parameters to evaluate such as a sample surface roughness, microsection for failure analysis, physical analysis using mechanical testing, using double lap joint test method and analysis of bond strength. This is a research methodology. I will start the background study. Next, material test, sample and equipment, followed by the test sample preparations. Testing process. From the testing, we get the data. We get the data collection and analyze for obtain the result and discussions and the conclusions. And lastly, I will conclude at the last slide for my presentation. This is experimental flowchart. First, material preparations. Second, semi-process activity, microsection process, bonding process, cleaning process. For the dimensional check, if the dimension, if yes, the dimension as per follow requirement, we proceed to testing. If no, we revert to cleaning process to dimension as requirement. After the testing, we get the data analysis and we conclude the result and analysis. This is a sample preparation for materials preparation for fiberglass lamination process, 0 degree, 12 ply of prepreg. After that, curing process, cure temperature 355 Fahrenheit, plus minus 10 Fahrenheit, pressure 85 plus minus 5 psi. After that, demo process at ambient temperature, which is the room temperature, and the last trimming process as per dimension at SN 3528. This is a sanding process activity. I use the hand sanding method for sanding frequency for 4 times, 8 times and 12 times for different grid size of sandpaper, 400, 600 and 800. For all samples, I do the 0 degree dimensions. As we can see at this slide, for optical microscope process activity, I use the width 400 for 4 times, width 400 8 times for time sanding, and width 412 times sanding frequency. I use this microscope to visualize the different surface roughness on the specimen. This is the surface roughness activity. I use the surface roughness machine model Mito CJ400. After we do the surface roughness activity, we get the reading values for 400 for grid size 400 sending frequency for 4 times sending frequency, we get the highest average surface roughness is 5.964, and the lowest we get the surface roughness reading values for 800 to 12 sending frequency 3.573. This is a flow, the process for bonding process activity. First, clean the surface due to sanding area with a suitable solvent. Second, mix high salt and hardener with the ratio 100:22. 3. Apply the mixture on the sanding surface using brush. 4. Place the bonded sample in the middle of cold plate and clamp press machine. 5. Place the bonded sample into the press machine for 10 to 30 psi and cure it at 80 degrees Celsius for 1 hour. 6. After 1 hour, take out from the machine and allow cool to the room temperature. 7. Remove tools from the samples. 8. Cut the sample according to testing standard. 9. Repeat the process to new sample frequency times 8 and 12. As we see that this is a bonding process. The picture show the test panel insert into the bonding jig. This is a press machine. Pressure 10 to 30 psi. Apply to test panel using electric press machine. And these pictures show the test panel after bond completed. Okay, this is a training process activity. This picture, the dimension, we want to test this Esporo at STM 3528, which is the width of the sample is 25.4 millimeter. For every each test panel, we must do the 3 specimen for 1 set. This is equipment and testing procedure. We do the double lap joint according to STM 3528. The first, placing samples. Second, we use the loading rate 1.27 mm per minute. And lastly, the recording, which is we get the result. This is the test pictures specimen. The upper and lower hydraulic gripper, which is we do the load test universal test machine Zwick or Z 400 kN. This is video for testing process. Okay, we proceed to result and discussion. As table show, the highest average sending frequency, preferred grid size 400 for 4 times sending frequency, 9.60 average bond stress megapascal. While the lowest bonding stress, we can see from the table, if we increase sending frequency to 12 times, to the data show the average bond stress equal to 4.26 for 400 grid size, 4.33 for 600 grid size, and 4.45 for 800 grid size. In my opinion, if we increase this stress, the sending, if we increase the sending frequency to 12 times, the average bond stress slightly equal to 4.34 megapascal. Okay, this is a average. This is a graph for average bond stress versus sending frequency. As we see that the 400 for grid size 400, sanding frequency for 4 times is the highest for average bond size. This graph is average bond size versus average surface roughness. As for grid 400 is the highest for average bond size, and the surface roughness is highest. From the result, we can analyze that each grid size of sandpaper have a different sanding frequency and bonding size. The lower grid size 400 give a better result when sanding frequency between 4 times and 8 times, while when sanding increase 12 times, it will give the lower average bond size. For the surface roughness, the higher average surface roughness and the lower sanding frequency provide more bonding strength due to the specimen based on the grid size of sandpaper, which is 400 is the best option. For the conclusion, based on the data analysis, we can prove that the grid size 400 will give best performance or result towards an average bonding stress and average surface roughness for bonding process. Therefore, we can conclude that by using grid size of sandpaper 400 is the best option to obtain the average bonding stress of GNRP double set joint during the process testing. The end. Thank you for watching my video.